All right, you're also today in geometry is going to be a little bit of a review from essentially with slope and equations of lines. All right, so a lot of it's from Algebra 1, but we're going to do a quick review kind of different formulas and some of those concepts. Okay, so we're going to have a little bit of a slope review. Okay, so slope review. Okay, first of all, let's talk about the word slope and what that means. All right, so slope is essentially the steepness of a line okay, but it also tells us if the line is increasing or decreasing. All right. Now, hopefully we remember it. All right, but essentially, right, it's the steepness of the line. Right, it's the rise over the run. Right, that might be one thing that you remember it as. Or other words, it's the change of y over the change in x. Okay, that's another way to think about it. Okay, but it kind of tells us, is it a kind of a more horizontal line or is it a more vertical line? Okay, or is it going down as x increases, or is it going up as x increases? Those are the types of things that slope tells us about the line. So let's hopefully we can jog our memory here. All right, but it's the rise over the run. That's one way to think about it. Okay, other words, in other words, it's the change in y over the change in x. So that little triangle represents change. All right, and the big kind of formula here is y2 minus y1 over x2 minus x1. So maybe this is kind of the most common formula, all right, because it's definitely one we'll be using. Okay, so this is like our slope formula. Okay, maybe we'll label that slope formula. Okay, and then just to give you a visual, right, also understand that we're working with points. So if this was the line, okay, the rise would be this part. Okay, that's the rise. And then the run would be this part. Okay, so the rise over the run, right, I would take this portion and then divide by this portion. Okay, so that's kind of a quick info bit on slope. Okay, now some more slope information, all right, is this time dealing with parallel and perpendicular lines, how those two relate. All right, parallel lines have the same slope. Okay, now think about it. We kind of have a line right here and then a line right here. If those two have the same slope, they are parallel, right? The only difference might be, if it's shifted up or down, okay? But they have the same slope, okay? Let's talk about perpendicular lines. Two options here, okay? One, okay, you can say that they have slopes that are negative reciprocals of each other. Okay, that's one way to think about it. Now, for example, what that is, right, because those are some big words, okay, negative reciprocal of each other, right? But, for example, let's say I had one slope that was 2/3, okay, and then another that was negative 3/2. Okay, that is an example of negative reciprocals. Okay, because what I'm saying, I'm flipping essentially the fraction, right? It was 2/3, now I'm flipping it, and it's now 3/2, and then I'm making it negative. Okay, so that's the negative part, right? It was positive, now it's negative, or it could go the other way around. And the reciprocal part is where the 2 is now on the bottom, right? And the 3 is now on top. Okay, another example, same situation. What if it was negative 5/7? Okay, so we would flip it. Therefore, the 7 is now on the top, and the 5's on the bottom. But notice this was already negative, so now I want this one as positive. Okay, so that's two examples as to how we can determine if lines are perpendicular. Now the other way to do this, okay, is to say that the product of the slopes is equal to -1. Okay, so two different ways to do it. Let's use those same examples. Two-thirds time. What does the product mean, right? The product is the answer in a multiplication problem, right? When you multiply two things together, you get out a product of them. Okay, so 2/3 times -3/2. Okay, we want that to be -1, and if it is, then the lines would be perpendicular. Okay, so the 2's here, right? We've got 2 on top, a 2 on the bottom. Okay, 3 on top, 3 on the bottom. So we've got 2 times -3. What does that give me? On top, that gets me -6. And then over on the bottom, right, is 3 times 2, which gives me +6. So it's -6 over +6. In other words, that is -1. Check, right? Because now we do know that they're perpendicular. Another example. Okay, that same one, right, with the 5/7, -5/7, and 7/5. -5 times 7, that's -35. 7 times 5, that's just +35. That one also does equal, whoa, my face, does equal -1. Okay, so those are how we can determine if lines are parallel or perpendicular. So again, as a quick review, parallel have this exact same slope, okay, -6 and -6, okay, or 3/2, no, let's use different numbers, 8/9 and 8/9, right? If they're the exact same, they are perpendicular, or sorry, they are parallel, okay? And then in order to talk about perpendicular, okay, that's where you're going to have the negative reciprocals of each other, or the product of the slope is -1. And it's just two different ways to do it, right? You can use this method to determine if they're perpendicular, and then you can use this method to determine if they're perpendicular. Either one of those works perfectly fine. I'm just giving you two options in which to work. Okay, and then let's also go over some information about equations of lines. All right, and then we'll get to some examples. Let's use a different note card. Okay, equations of lines formats. Okay, equations of lines formats. All right, first one, everyone's favorite, slope intercept form. Okay, slope intercept form. All right, hopefully we remember this again from Algebra 1, but if not, that's okay. This is everyone's favorite, y equals mx plus b. Okay, now the reason it's called slope intercept form is because it gives you the slope and it gives you the intercept, right? If it's already a written out equation of line, you will have both the slope and the intercept. Here's why. M is the slope of the line. B is the y-intercept. Okay, now as a reminder, okay, the y-intercept is where the line intersects the y-axis. Okay, so that's where the line intersects the y-axis. Okay, so if it was a slope of 10, you would instead put 10 here. You're going to leave y, you're going to put the equal sign, and you'll put 10. You're going to leave x. Okay, and then if the y-intercept was -5, you're going to put -5 here. Okay, that's slope-intercept form. Let's talk about the other common form, or one other common form. This is point-slope form. Now, just like slope-intercept form, it is called this because it gives us a point and it gives us a slope. Okay, so let's go ahead and look at it. Y equals, cross that out. Y minus y1, apologize for that, equals m times x minus x1. Okay, So that's the form we're working with in point slope. Now let's go ahead and look at it again. M was the slope, and we are luckily consistent here. It is still the slope, all right? They both have slope in their equation. Okay, and then the more complicated one, people get a little bit confused with this, is these two pieces right here. X1 and Y1, okay? And what it is, right, is it is X1, comma Y1, okay, is an actual point on that line. Okay? It is a specific point on that line. Okay? Like a tangible point, right? Like 2, 7. Let's say 2, 7 was on that line. I could do 2, right? Because 2 is my x, 7, and put it on that format. Okay? And again, we'll look at examples of this, but that's essentially what two most common equation of line formats that we're working with. Okay? There's also standard form. Standard form isn't as helpful, okay, but it is still a thing that exists. But for this class, we are going to focus on slope, intercept, and point slope form. Okay, so as an overview, okay, we've got the slopes, right? We got slope, parallel, same slope, perpendicular, negative reciprocals of each other, equations of lines, slope, intercept form, and then point slope form. Let's look at some examples. Okay. Now, the rest of these notes go over essentially what I just went over. All right. So we're going to go ahead and look at 1 and 2 here. And we're going to look at the instructions first. Okay. So it says determine whether MN, the line MN, and line RS are parallel, perpendicular, or neither. Okay. And then graph each line to verify the answer. We're not going to graph just because we're going to graph towards the end of this, and we'll get our practicing for graphs in when we get there. Okay, let's just go ahead and do the slopes. All right, so for number 1, okay, we want to find first the slope of MN, and then we will compare it to the slope of RS. So let's do slope MN. Okay, that's what we're going to do here. Okay, now remember it's Y2. Okay, slope formula. We'll go ahead and write that maybe down here so we have it to reference. Slope formula. Okay, y2 minus y1 over x2 minus x1. Okay, I remember that because of rise over run, right? Rising is like the difference between your y's. Run, difference between your x's. As long as we're consistent, that'll work. Okay, and I'm going to treat these right, this is like they're kind of split, right? So it's M and N. We'll treat those two together, right? So it's Y2 first, okay? Y2 minus Y1, okay? So 4 minus 3, okay? Again, that's my second Y coordinate. This is my first Y coordinate, okay? And then we'll do my second X coordinate minus my first X coordinate. So 2 minus 0. So 4 minus 3. 2 minus 0, okay, I end up getting a slope of 1/2. Let's go ahead and compare that to RS. And maybe we'll cover up this other one so we don't get confused. I guess with this, that fancy thing. Okay, now we're going to do the slope of RS. Okay, so here we go, same process. All right, we'll do 4 minus 1. This is my y2 minus y1 over x2 minus x1. Okay, and then we'll get 4 minus 1, 3, and then 8 minus 2, 6. Now, initially, these don't look the same, do they? Right? 1/2, 3/6. But, don't forget, a 3/6 is 1/2. Right? We could reduce this fraction down to this, and so we do get the same. Therefore, we'll go ahead and say same slope. So, parallel. for number 1. Okay, that is the work on number 1. Okay, flipping to the back. Okay, maybe let's do number 2 now. Okay, number 2. Maybe those lines are confusing. New note card. Okay, number 2, here we go. Okay, same process. All right, we are determining the slopes of Mn, slope of Mn, and then slope of Rs. Okay, so here we go. Slope of Mn. Y2 minus Y1. 5 minus 3. X2, 0, minus negative 1. Okay, careful. Right? When we subtract a negative number, you've got to be very careful. So we've got 0 minus, because that's my formula, minus negative 1. Okay? Which, don't forget, that turns into a plus. Okay? So I end up with 2 over 0 plus 1. That is 2 over 1, that's 2. That's my slope. Slope of Rs. Okay, negative 1, that's my y2. y2 minus y1. y2 minus y1. Okay? Right, so start off with the negative, so that's why it's always easier to subtract a positive. Okay? Anyways, x2, 6, minus x1, 2. Okay, so negative 1 minus 1. Okay, so I'm in the negatives, but then I'm going further negative by subtracting that 1. So I'm at negative 2 over 6 minus 2, that's 4. Okay, so negative 2 over 4. What can we convert that to? Well, that's negative 1/2. So now what we're doing is we're comparing these. Okay? So do we think that these are parallel? No, they're not. Not parallel. They're not the same. Okay, they're not the same value. Do we think they're perpendicular? Not just based on the way that I said that, because I was obviously kind of like leading you there. The answer is yes, they're perpendicular. Okay? So look. This is one perfectly okay format to write 2. Notice it's 2 over 1. Then we flip it, right? Again, right? The 2's on top, but the 2's on the bottom here. 1's on the bottom here. 1's on top. And it's negative. 1 was positive, 1's negative. So these are negative reciprocals. Are negative reciprocals. Therefore, that symbol, or perpendicular. Whew, that was close. Perpendicular. Okay? So, these two are perpendicular. All right? And that is the work for number 2. Okay? Make sure you're very organized with it, right? Don't just try to skip steps, right? Take each step diligently. Slope of Mn, slope of Rs. Compare the two slopes. And then you can determine if they're parallel, perpendicular, or neither, right? Neither, just to throw it out there, right? That means they're not the same and they're not negative reciprocals of each other. So maybe the numbers have nothing to do with each other, okay? Alrighty, that is a parallel, perpendicular, or neither. Okay, let's go ahead and let's do one example of finding the slope on the graph. Okay, finding the slope on the graph. All right, good practice here. Okay. So it says find the slope of each line, and we're trying to find the slope of CD. Okay, so I got to locate C in the picture. Here's C. It even gives us the coordinates. Thank you, because, you know, anytime we get more information than needed, it helps us, right? So it gives us the coordinates here. We're looking at C, we're looking at D. Okay, so I'm trying to determine the slope of this line right here. Everything else is just extra information, right? Extra information. So one way to do this is to do rise over run, and frankly, when we have a picture, I like to do rise over the run. So I'm going to start at this one, okay, and I'm going to count how far I have to go for my rise. Okay, so I'm going up 1, 2, 3, 4. Okay, so that's, since I was starting from here and I went up 4, I'm going to make that a positive. Okay, because again, I'm going up, right? I was starting here and I went up. Okay, so going up is positive. If I were to go down, I'd have to make a negative. Okay, so then I'm here. And then how do I get to the point? Well, I'm going over to the left 2. So 1, 2. Okay, so I'm going to go ahead and write 2, but is it positive or negative? It's negative because I'm going to the left. 1, 2. So I'm gonna have to make this entire thing negative, the entire thing. Right? Now, you could just put the negative 2, but really what it is it's the entire thing. So I've got negative 4 over positive 2, and then this can convert to negative 2, so that's your slope there. Okay, a slope of negative 2. All right? We could do more examples, right? But, you know, it's essentially the same thing each time, right? You're looking at your rise over your run, right? As you go up or down, that's your rise. And then as you go to the left or to the right, that's your run. Okay? Again, up is positive, down is negative, left is negative, and then right is positive. Okay, so that's slope. All right, equations of lines, okay? All right, so here are the instructions. Write an equation in slope-intercept form. Okay, so that's y equals, as a reminder, mx plus b, okay, where m is your slope, b is your y-intercept. And then graph the line. So this is where we'll practice our graphing. Okay? All right. So for number 1, it gives you m and it gives you b. Man, I mean, that is just, it gives to you, right? You literally write it into that formula, right? So y equals, instead of m, 2. So it tells you the slope is 2. X, I continue. And then b is negative 3. So plus negative 3, in other words, just minus 3. That's my equation, okay? Y is equal to 2x minus 3. So let's graph it. Okay, let's get our graphing paper out. Okay, for number 1, all right, maybe we'll have, you know, here's your y-axis, here's your x-axis, okay? I always like to start, let's label everything. I always like to start with my y-intercept, okay? And in fact, really, it's the only way you can do it, okay? So you start with your y-intercept, negative 3. It intersects the y-axis at negative 3. So I'm going to go to negative 3, 1, 2, 3. There's negative 3. And then I'm going to apply the slope from there. Well, remember, okay, this slope is 2. But remember, your slope is always rise over run. So what is going to be our run? Well, 2 over 1, right? I can rewrite this as 2 over 1. So up 2, 1, 2. And which way for your run? Well, they're both positive, okay? So positive, positive. So over 1, okay? And I just apply that the whole time. Up 2, over 1. Up 2, over 1. And that's your line, okay? So from there, right, it doesn't have to be perfect, but maybe make it as straight as possible. But essentially, that's it. That's your line for number 1, okay? Cool. And one thing to point out is just remember, let's say you accidentally went to the left, okay, to count. Okay, your rise would be a negative 2 here, and then your run would be a negative 1. So, but they would end up being a negative over a negative, so it would end up still being a positive. Just something to consider, okay, because sometimes it does get confusing with that. All right, number 2, okay, negative 1/2, and a positive slope. In fact, I said I was going to do 3. We're not going to do 3. We're going to do 2. Okay. So here we go again. Right. Y equals, instead of m, I write negative 1/2 x plus b, which is 4. Okay. And let's go ahead and graph it. Number 2. Okay. Similar process. All right. Similar process here. Here's my graph. Y and x. Y-intercept of 4. 1, 2, 3, 4. Okay? And then notice I've got a negative slope here. It's just something I'm going to have to remember. Okay? Let's make my rise negative. Okay? And then we'll make my run positive. Okay? But it doesn't matter. As long as you make one positive, one negative, you've taken care of your rise over your run properly. Okay? So I'm going to go down negative 1. Or really, I should say go down 1. Okay? So go down 1. You've taken care of your rise. Okay, you've taken care of your rise. And then you run positive 2, 1, 2. Okay? Down 1, that's the negative part. Positive 2. Okay? Down 1, negative, positive 2. And you can see that your function is decreasing as x increases. What I mean by that is, as I go to the right, notice my y is going down. Okay? And over here, notice as my x increases, as I go to the right, my y is going up. Okay? So there we go. Those are our two equations. Okay? Number 6. Number 6 is a little bit different. Okay? Number 6 is a little bit different. And let me preface it with this. There are so many different ways to solve this problem. Okay? Multiple. There's multiple different ways to do it. Okay? I'm going to give you one way. All right? I'm going to give you one way to do this. But this way might not work for you. Okay? I just want to say that there's a lot of different ways to do this. If you can understand what the kind of the situation is with lines and slope and y's and x's and b's and all that and graphs, you can definitely do this a different way. All right? I just want to say that. But this is the way I like to do this. Okay? So it says I need it in slope-intercept form. Okay? So that's my goal. I want y by itself equals mx plus b. Okay? And notice what I'm given. This time I'm not given my m and b. Okay? So it makes it a little bit harder, but that's okay. We're not going to panic, right? We're going to slow down. We're going to assess what we have. Okay? I do have the slope here. That's something to point out. Okay? I have the slope. And then over here, what do I have? Well, I have an xy coordinate pair. Okay? In other words, I have a point. Well, do we have an equation of a line format that uses the point and the slope? Yes, we do. We have point slope. Okay? This right here. Let's get our little notes. Point slope form right here. Okay? So I could write it into point slope form and then just try to convert it to slope intercept. That's the way I personally like to do this. So I'm going to go ahead and do it that way. All right? So let's go ahead and work on this one. Okay? Here's my slope, point slope format. Y minus y1 equals m times x minus x1. And let's label everything. Okay? You already have your m. X, that's going to be your x1. Right? That 1 is going to be your x1. That negative 11 is going to be your y1. So from here, I plug in everything, and then we're going to think about how we can convert it to slope-intercept. Okay? So anyways, here we go. Y minus y1. Well, what is your y1? It's negative 11. It's that double negative thing again. Okay? That's okay. All right? Equals negative 3 times x minus 1, because that's your x1. Okay? So we're just plugging everything in, right? I just took y1. Boom. Negative 11. Double negative. That's all right. Now let's go ahead and evaluate. Okay? And actually, before we evaluate, I want to think about what form I want it in. Okay? This is the form I want it in, right? Y equals mx plus b. Let's think about what defines this format. Are there any parentheses in this format? No. No parentheses. No. Okay? That means I got to get rid of parentheses here. Is there anything with y on that side of the equation, on that left side of the equal sign? No, it's just y. Okay, so really that's the two parts that I need. I want y by itself, and then I want to get rid of the parentheses. Okay, so let's go ahead and do that. Let's get rid of the parentheses. Actually, we're going to do 2 steps on this particular one. Okay, I'm going to do y. I'm going to get rid of this double negative. We don't like that. So y minus negative 11. That's y plus 11. Okay, equals, and then we're going to get rid of the parentheses this step as well. Okay, in order to get rid of parentheses, well, we're going to distribute. Okay, we're going to distribute here. We got negative 3x, okay, and then negative 3 times negative 1, that's going to give me plus 3. Okay, so no parentheses. I'm so close. The only thing that I don't have is I have that value y plus 11. I just want y. Remember, slope-intercept form is just y by itself. Well, how can we get rid of that plus 11? We are adding 11, so in order to get rid of it, we will subtract 11. So I end up with y equals negative 3x, 3 minus 11, so minus 8. Okay? There we go. Let's graph it. And then we're going to see something pretty cool on the graph here. We're going to see something pretty cool here. All right? So this is the the work for number 6. Okay? And let's graph it. Okay? So here we go. All right. Okay, so a slope, as a reminder, let's put this under. Here's our work. Don't want to miss that. Okay. That's the equation I'm going to graph. Okay. All right. So minus 8 as my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. Wow, look at that. Perfect. Okay. There's my point. And then I have a slope of -3. Okay. So rise over run. Remember, we could let's just kind of write out the slope here. It's -3 over 1. Okay. So if I go up 3, maybe let's just do this, right? If I go up 3, have I taken care of my negative? No, I haven't. So I've got to take care of my negative. Boom. There we go. Okay. Could you also do it from here to here? Sure. -3 over 1, right? Okay. And then we'll just continue that slope. Okay. But the cool thing here is this. Watch. We can double check our work. That's always a good thing. Okay. There's my graph. All right. There's my graph. Okay. And then let's just double check something. Okay, the slope -3, right? Okay, it still remained the same. And do I have that point on my graph? Well, I better. I better have that point on my graph. Okay, well, let's double check. 1, -11. 1, and this better be -11. So let's see. 1, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is, -11. Okay, so that means we did it right because we have that point on the graph. Remember, that's what it's saying, right? I have to have that point on the graph with that slope. Okay? And there we go. All right? And then let's go ahead and do one more, just number 7, and this will be our last one. Okay, write an equation, this time in point-slope form. Well, we actually practiced that a little bit here. Okay, but we're going to go ahead and do it again. Okay, point-slope form. All right, the format, again, is y minus y1 equals m times x minus x1. And that's just this point slope form, okay? That's what it's called. It's got a point and a slope, all right? And then this is your slope, okay? This is your x1, y1. Okay, so y minus -1, again, that double negative, okay, equals 1/2 times x minus 3. Okay? And remember, this time I actually want to keep it in 2-point slope form. So all I'm going to do is just get rid of that negative. That's it. Y plus 1 equals 1/2 times x minus 3. That is in point slope form. The only thing I did is I just got rid of that double negative because no one likes that. Okay? And that's point slope. Okay? Now, to actually graph point slope, it's really not bad because you just go to the point. Okay. The only difference really is on slope intercept, right? You go to the intercept first and then you apply the slope. Okay. But with point slope, you're going to go to the point and then apply the slope. Okay. So here we go. We're going to go ahead and graph this one, and that will be it for today. All right. So number 7. Okay. 3, -1. Let's go ahead and draw our graph here. Okay. 3, -1. Okay, that's the point, right? That's that point that it's telling us is on that. That's the point that's telling us is on that line. Okay, and then I'm just going to apply the slope 1/2. Up 1, right? Rise, run 2. Up 1, rise 2. Sorry, rise 1, run 2. Okay, rise 1. That is so hard to say. Rise 1. Run 2. Okay, that's something. Okay, and so that's our equation, right, for this one, because I'm starting at that point 3, -1. So I go over 3, -1. That's my point, and then I apply the slope. This is just kind of my work. Don't get confused with that. That was me counting. Okay, so here's my line, and then we could just continue that and keep going. Right, keep going as long as you want. as long as you feel like you have a good feel for the line. Okay? Now, something to keep in mind, that would be your y-intercept. Okay? Just something to keep in mind. If I were to write it into slope-intercept, we could use that. Okay? Just throwing that out there. All right, guys. That is it for today. All right? You guys have a great rest of your weekend. I don't know why I said that, because it's the weekend when I'm making this, but you're definitely not going to be watching this on the weekend. It's crazy. Anyways, you guys have a great day. Y'all take care. See you later.